Hello Newtonians. Welcome to the Required Skills for Mechanical Design Engineers video series. In this series, we're zeroing in on 8 key skills every mechanical design engineer needs to excel. Dive into individual videos for focused insights, or watch our all-in-one video for the full rundown. The skills listed here are based on my opinion and experience. Analytical and problem-solving skills. In simple words, analytical skills are the ability to analyze information and draw conclusions from it. Problem-solving skills are abilities to identify and understand a problem and solve it. In our line of work, we all use these skills, whether we know it or not. We are constantly analyzing the information that we receive, and we are drawing a conclusion from it. For example, if I change feature A, that will influence feature B. The outcome of our analysis is highly dependent on the information we gather. The more information we have about the specific subject, the better conclusion we can draw out. I will try to give you a generic example. Let us imagine that we have a product that sometimes fails and sometimes does not. The first thing we have to do is gather information about how many products failed from how many. This information will immediately give us an idea of how severe the problem we are facing is. 10% or 50% is a big difference. Also, in most cases, higher the percentage of error, the easier it is to figure out what is wrong, not necessarily easier to fix. The next step is to figure out under what conditions we have a failure. That means that we will, depending on our problem, start collecting information about the failure. You will talk with the person who reported the failure or read the report about it and what led to it. We could have two scenarios. The failure mode is known. If the failure is known, for example, I did A, and then failure happened, then we can move forward by replicating the steps that led to the failure to prove that was the case and that there were no other conditions contributing to this failure. Once we prove that was the reason for the failure, we can proceed with analyzing if this failure should or should not have happened. That means reviewing our user cases, calculation reports, intended environment, product specifications, etc. This will give us information on whether we should continue with our analysis. For example, our product is rated up to -10 degrees Celsius, but it was in an environment that was on -20 degrees Celsius, and failure occurred. The decision if we are going to upgrade our product or not to fit this use case is not a concern in this analysis. In case that failure occurred when it was not supposed to happen, we must proceed to gather more information on what could have led to this failure. Depending on the failure, you will measure the components, check the tolerances, and tolerance stack up, investigate the assembly process, look into the defined loads, and compare them with the loads that appeared during the failure. We will basically not leave one stone unturned until we truly understand the reason behind it. The result of our analysis should be a clear problem statement. For example, the failure on the 3D printer that resulted with the printing head colliding with the print bed was due to the distance sensor being mounted too high during the assembly process. The failure mode is unknown. If the failure is unknown, for example, it was laying on the desk, and out of nowhere, it failed, we first have to determine the reason for the failure. So we are going to start by analyzing the failure and its outcome and then assume different failure modes and proceed with experiments until we prove the reason for failure. Once we do that, the steps afterward are the same as in the previous scenario. Usually, with this approach, we will already have some information about what could possibly lead to the failure. Once we get our problem statement, we can proceed with solving the problem if needed. The first step is to define what exactly we want to achieve by solving this problem. Sometimes, it will not make sense to solve the complete problem but a fraction of it. This will require a decision to be made. Next chapter. Basically, we will decide either to solve the whole problem, part of it, or none of it. Yes, sometimes doing nothing at this point of time is also a solution to a problem. The next step is to generate possible solutions. In our previous example of a 3D printer's sensor being mounted too high during the assembly process, we can have multiple solutions like updating the assembly instructions, creating a fixture for mounting the sensor in the proper position, redesigning the sensor's holder, and updating the drawing. After we generate the solution, we must analyze it. Which solutions give us the highest value with the minimum resources spent? Maybe we could combine two solutions, one used as a short-term and the other as a long-term solution? What would it take us to implement it? Naturally, after this previous step, next step is to make a decision. Our final step is to plan and implement this solution based on our decision. For our previous example, the short-term solution is to update the assembly instructions, and the long-term solution is to redesign the sensor's holder so that it is impossible to mount the sensor too high. Analytical and problem-solving skills are highly valuable skills to have. We are using them all the time, and we should keep developing them. These skills could be a big differentiator between you and others. Here are some tips. Always keep your mind open to new ideas. No matter how stupid the idea you think it is, it might lead to other valuable ideas or insights. No matter how stupid you think that your failure mode is, consider it. No matter how stupid you think they are, the warning labels were put with the reason. Someone actually did what the warning label is saying not to do. I saw a warning label saying, "Do not put your credit card in the opening for the parking card," and I am pretty sure it was not there without a good and funny reason behind it. Always gather information on the products you are working on and similar products to yours, and have a designated place to store that information. You never know when a similar problem will occur to you, and you will want to have a head start on your information gathering process. Learn supporting techniques like problem analysis, root cause analysis, fishbone diagrams, the 5 whys technique, etc. Learn how to ask good questions. Learn how to use techniques for generating ideas, like brainstorming. Keep pushing even when you think you are not going anywhere. Sometimes, the correct insight will come when you are not expecting it. Properly document your process and experiments. My approach is like this: if I go for 2 weeks of PTO next week, will I be able to continue when I am back? If the answer is no, I know that I need to better document my progress. If you are using abbreviations, always write down the legend. It happened to me more than I would like to admit. I would look into my poorly written notes and wonder what GLUC and GRUC meant. When being asked your opinion about different problems or failure modes, you can give your opinion, initial gut reaction, but always make sure that you finish your thoughts with, "But in order to have the better answer, I would need to conduct proper analysis to draw out correct conclusions." Do you have any questions for us? Let us know in the comments below. Do you like our videos? Then, give us a thumb up, comment, and share it with your friends, colleagues, and on your social media channels. And if you want to become a part of the Newtonians, make sure to subscribe to our channel.